Hello there! We are intended to solve the area of the given oblique triangle for this video. Our triangle here has values for all of its sides. We have 7 here. We also have 6 in this side and 9 on this side. All of the sides of this given oblique triangle are given. No other values are given. I'm talking about no interior angle measurements, and hence we will be going Hello there! We are going to solve for the area of this given oblique triangle. Notice that for this oblique triangle here, all side measurements are given. We have here 7, we have 6 units and 9 units. In solving the area of a given oblique triangle, we need to identify the given measurements first. We have 2 different formulas, one of which is a formula that involves a measurement of an included angle, and the second is a formula we're going to use in solving this given oblique triangle. This given triangle is part or an example of an SSS Oblique Triangle, where it's all the sides that are given. We cannot use here the usual formula for the area of a triangle, stating the area is equal to 1/2 the product of base times height, because we need to identify the length of the height first, in order for us to solve for the area. But since again we don't know the exact measurements of the angles here, we cannot use any concept for the right triangle that can be formed using the SOHCAHTOA, because even if we know this is the opposite side of an angle here, we don't know the measurement of this side, part of 9. We are going to use here the formula, or we also known as Heron's formula. Heron's formula. This formula uses the measurements of all sides and trying to determine the relationship of those sides in getting the area of the triangle. We have 2 steps here. The Heron's formula is computed as the square root of the product of S times the difference of S minus A times the difference of S minus B and times the difference of S minus C. Now for this, A, B, and C are all the given side measurements. It's up to you which side you prefer to be called A, B, or C. Doesn't matter, because for this operation, it's multiplication, and multiplication is commutative. The problem now is the measurement of S. Now S here is also known as a semi-perimeter of the triangle. S can be computed as the result when you added up all the side measurements and divide it by 2. Again, by 2, not 3, because we're not looking for an average. We are going to divide the sum of all the 3 sides by 2. So in this case, S can be computed as, let's say, A is 7, and then B is 6, and C is 9 over 2. So for this, 7 plus 6 is 13, plus 9 is 22, divided by 2, we have here 11. Again, 7 plus 6 is 13, plus 9 is 22, divided by 2, 11. So this is the value of S, where we are going to apply here even in these differences in solving the area of this given oblique triangle. So this can be rewritten by substitution 11 times. S is also 11 minus 7 here as what we used as earlier. We also have 11 minus 6. And then you have here 11 minus 9. Notice that the value of S should be longer than all of the 3 remaining sides so that the differences will become positive. It is because if one of which is a negative result, we can have an undefined value for our area since there is no square root of any negative number. Now we are going to implement this in your calculators. Let me use this calculator. So we are going to input all of this at once. So you have 11 times 11 minus 7, if I'm correct, is 4, times you have 5 for 11 minus 6, and times 2 for 11 minus 9. So you have 11 times 4 times 5 times 2, so you have 440. But please do not forget the square root symbol because we are still to get the root of it. So let me extend this here. So when we take the root of that, since it's an area, of course, it's already positive, we will just simply take the square root of the answer. Pardon? Equals, you'll have the square root of the answer, which is 440, and it gives us the result of 20.97617, so on and so forth. We are just going to use rounded off value in 2 decimal places. That would mean it would become 20.98, and that is actually our exact value, or rather approximated value, not the exact. So we have here approximately, again, 20.98. That is the area of this given oblique triangle. But to complete its notation, since it's an area, we will be using square, and you will have here units since we don't have specific unit of measurement. So this is the area of this given oblique triangle using the Heron's formula, which is applicable for SSS situations. We also have this and this process.